Let us show that the angle between the two polar curves is pi by 2. So they are orthogonal, means the angle between the two polar curves is pi by 2. First, let us consider the given two curves and let us calculate the angle between the radius vector and the tangent vector for both the curves. So using this relation, what is that? It is cot phi equals to 1 by r dr by d theta. So using this, let us calculate this. So consider the polar curve. Now apply log on both sides. Now differentiate with respect to theta. The differentiation of log r is 1 by r dr by d theta. The differentiation of log a is 0. The differentiation of log function is 1 by function into differentiation of function. Here the function is 1 plus cos theta. The differentiation of 1 is 0 and the differentiation of cos theta is minus sin theta. But we know that 1 by r dr by d theta is cot phi. We know that sin 2 theta is 2 sin theta into cos theta. So as a consequence, sin theta is 2 sin theta by 2 into cos theta by 2. We know that 1 plus cos 2 theta is 2 cos square theta. As a consequence, 1 plus cos theta is 2 cos square theta by 2. So finally we have sin theta by 2 by cos theta by 2, which is tan theta by 2. But minus tan theta by 2 is nothing but cot of pi by 2 plus theta by 2. So here pi by 2 plus theta by 2 will come in the second quadrant where sin family is only positive there. So we have minus here. On comparison, we can say that phi equals to pi by 2 plus theta by 2. So let us call that as phi 1. In similar manner, let us calculate the angle between the radius and tangent vector for this another polar curve. Apply log on both sides. Differentiate with respect to theta. The differentiation of log r is 1 by r into dr by d theta. Differentiation of log a is 0. The differentiation of log function is 1 by function into differentiation of function. So here the function is 1 minus cos theta. The differentiation of 1 is 0 minus the differentiation of cos theta is minus sin theta. So we have, so again sin 2 theta is 2 sin theta into cos theta. As a consequence, sin theta is 2 sin theta by 2 into cos theta by 2. And we know that 1 minus cos 2 theta is 2 sin square theta. As a consequence, 1 minus cos theta is 2 sin square theta by 2. And we have cos theta by 2 by sin theta by 2 is cot theta by 2. By comparison, I can say that. So phi equals to theta by 2. So let us call it as phi 2. Now the angle between the two planar curves is given by the modulus of phi 1 minus phi 2. Let us substitute the value of phi 1 and phi 2. I can cancel theta by 2 here, so that remaining thing is pi by 2. So therefore, the angle between the two planar curves is pi by 2. Therefore, I can say that these two planar curves are orthogonal to each other. Now let us solve the next question. Obtain the radius of curvature for the curve at 2a comma 0. So let us consider the given thing, and we know the formula for the radius of curvature. Let us consider the given thing here. Now let us multiply this. So we have, so y square equals to, so let us multiply this 4a square by x to 2a. It is 8a square into a is 8 cube by x minus, so 4a square by x into x. So I can cancel 1x here. So that the remaining thing is, now differentiate with respect to x. The differentiation of y square is 2y into dy by dx. That is equal to, so here 8a cube is constant. The differentiation of 1 by x is minus 1 by x square minus the differentiation of 4a square is 0. So that the remaining thing is, so we can cancel 2 1s are 2 4s are here, and we can bring this y to the right hand side so that we have this. Now look at this. At 2a comma 0, we have to calculate this, right? See, at 2a comma 0 means, so at 2a comma 0 means we have to substitute x equals to 2a and y equals to 0 in this. So what is dy by dx here? So look at the denominator. If I substitute y equals to 0, it is indeterminate, right? It is infinity. So we have to consider dx by dy now. So since dy by dx is not defined, so we have to consider dx by dy. So if dy by dx equal to this, what is dx by dy? Just take the reciprocal of that. it is x square y divided by minus 4a cube, right? Now at 2a comma 0, that means we have to substitute x equals to 2a and y equals to 0. So what is dx by dy? So that is equal to, if I substitute y equal to 0, the whole thing is 0 here. So we have 0 here. So now we have dx by dy equals to x square by y divided by minus 4a cube. Let me consider that. So let me differentiate with respect to y on both sides. So the differentiation of dx by dy with respect to y is d square x by dy square. That is equal to, here the constant term is minus 1 by 4a cube is constant, and we need to differentiate this x square into y with respect to y, right? So this is nothing but minus 1 by 4a cube. We have to apply the product rule here. So first function, and the differentiation of y with respect to y is 1, plus second function, the differentiation of x square with respect to y is 2x into differentiation of x with respect to y. So we have at 2a comma 0, that means we have to substitute x equals to 2a and y equals to 0. So d square x by dy square will be, so minus 1 by 4a cube, we have to substitute y equal to 0 and x equals to 2a. So x square, so 2a whole square is 4a square, plus y is there, and 0 into anything is 0. So it is, I can cancel this minus 1 by 4a cube into, so 4a square. I can cancel this 4 and I can cancel this a square, so that the remaining thing is what? It is minus 1 by a. So we have the values of dx by dy and d square x by dy square at 2a comma 0. Now the radius of curvature formula will become, so 1 plus, here we considered a dx by dy whole square, not dy by dx. It is dx by dy whole square whole power 3 by 2 divided by d square x by dy square, right? So we have to calculate the radius of curvature at 2a comma 0. So at 2a comma 0 we have to calculate this. So we have to calculate the radius of curvature at 2a comma 0. So it is 1 plus, we know the value of dx by dy at 2a comma 0. What is that? It is 0. 0 square is 0 whole power 3 by 2. So divided by, we also know the value of d square x by dy square at 2a comma 0, which is minus 1 by a. So what happens? It is 1 power 3 by 2 is 1. So 1 by minus 1 by a, we can say that it is minus a. So therefore the radius of curvature is minus a. So now let us solve the next problem. So find the Maclaurin series expansion for log of 1 plus x. So that is given by, let y of x equal to, so log of 1 plus x, right? Let me substitute x equal to 0 to get y of 0. So y of 0 equal to 0. So let us differentiate this y with respect to x. The differentiation of log of 1 plus x is 1 by 1 plus x into differentiation of 1 plus x, which is, the differentiation of 1 is 0 plus the differentiation of x is 1. So we got y dash of x equal to 1 by 1 plus x, and what is y dash of 0? Substitute x equal to 0, it is 1 by 1 plus 0, which is nothing but 1. Now let me do the cross multiplication here. So now differentiate with respect to x. So we have to apply the product rule here. So first function, the differentiation of y dash is y double dash of x, plus second function y dash of x into differentiation of first function is 1. 1 plus 0, which is 1. That is equal to differentiation of 1 is 0. So we have this 1 plus x into y double dash of x plus y dash of x equal to 0. Now substitute x equal to 0. So we have y double dash of 0 plus y dash of 0 is 1. That is equal to 0. We can say that y double dash of 0 is minus 1. Now again differentiate this with respect to x. See what happens. We have to apply the product rule here. So 1 plus x, first function, differentiation of y double dash is y triple dash, plus second function into differentiation of 1 plus x is 1, plus the differentiation of y dash is y double dash of x, and the differentiation of 0 is 0. Now just substitute x equal to 0, but here y double dash of 0 is minus 1, so it is y triple dash of 0 plus 2 times minus 1, that is minus 2, which is equal to 0. So I can say that y triple dash of 0 is equal to 2. So now let me differentiate this with respect to x again, because we need to find the Maclaurin series up to 4th degree, so we have to calculate up to 4th derivative, right? So here it is first function, the differentiation of this. So first function into differentiation of y triple dash of x is the 4th derivative of x, plus second function the y triple dash of x into differentiation of 1 plus x is 1, plus 2 times the differentiation of y double dash is y triple dash of x, that is equal to the differentiation of 0 is 0. Now substitute x equal to 0. So now we have the 4th derivative of y at 0 plus 3 times y triple dash of 0 equal to 0. So I can say that the 4th derivative of 0 plus 3 into the y triple dash of 0 is 2, 3 2 is 6, that is equal to 0. I can say that the y 4th derivative is minus 6. Now let me consider the Maclaurin series of y of x up to the 4th degree. Now substitute the value of y of 0, y dash of 0, y triple dash of 0, y triple dash of 0, and 4th derivative of y at 0. We get, so now we have, see, log of 1 plus x, that is equal to x minus x square by 2, so 2 1s are 2 3s are, plus x cube by 3 minus x power 4 by 4. So using this I can calculate the log of 1 plus minus 6 value. So what is log of 1 plus minus 6? It is equal to, just replace x by minus 6, it is minus 6 minus minus 6 whole square divided by 2 plus minus 6 whole cube divided by 3 minus minus 6 whole power 4 divided by 4. Now this is equal to what? So log of 1 plus minus 6 is log of 1 minus 6, that is equal to minus 6 minus minus 6 whole square is x square divided by 2, minus 6 whole cube is minus x cube by 3, and minus 6 whole minus 6 whole power 4 is x power 4 by 4, right? Now let me consider this, right? So this is log of 1 plus x by 1 minus x whole power 1 by 2. So we know that log m power n is n into log m. So it is 1 by 2 into, so log of 1 plus x divided by 1 minus x, right? So this is equal to, so 1 by 2 times, so what is log of m by n? It is log m minus log n. It is log of 1 plus x minus log of 1 minus x. Now let us substitute these values. So we know these values, let us substitute them here. It's 1 by 2 times log of 1 plus x. What is that? It is x minus x square by 2 plus x cube by 3 minus x power 4 by 4 minus log of 1 minus x. It is minus x minus x square by 2 minus x cube by 3 minus x power 4 by 4. So here we have plus x and minus into minus x, okay, that is 2x, and here you have minus x square by 2, here minus into minus plus x square by 2, we can cancel this, and x cube by 3 and minus into minus plus x cube by 3, so minus x power 4 by 4 minus into minus plus x power 4 by 4, we can cancel this, so that the remaining thing is, so we can take this 2 common and cancel with this, so that the remaining thing is, it is x plus x cube by 3.